Good evening. Let's look at question 9 from exercise set 2.5. This is calculus. I'm looking to prove the formal definition of this limit, the limit as x approaches 3, x squared plus x, and I want that to be equal to 12. And I know it is equal to 12, but I need to prove it. I'm letting delta be this weird minimum of epsilon over m and 1, and you're going to see that this is going to come into play in two different places as I set up the formal definition of this limit. So let me lay out the formal definition of the limit. I know that if this limit is true, that means that when x is within delta units of 3, x minus 3 absolute value, then, then this implies that the function value, x squared plus x minus the limit 12, is within epsilon units here. So let's take advantage of my assumption of this minimum form here. I know it seems a little bit weird that I have this minimum form, and I'm going to use it in two different ways. First, if I assume that delta is less than 1, and I'm using the first assumption here, then I can use that in the left side. If I assume that delta is less than 1, then that means the absolute value of x plus 3, or x minus 3, is less than 1. So I'll set that out to be between 1 and negative 1. And that looks pretty nice. How does that help me? Well, to know how that's going to help me, let me look at the other side of this statement. X squared plus x minus 12 factors into x plus 4 times x minus 3. Oh, there's x minus 3. Wouldn't that be really nice? So what I'm going to do, because I see this x minus 3 here, I can't just assume, for example, that I'm going to let this x minus 3 be less than epsilon over x plus 4, for example. And I'm not allowed to do that division because this epsilon is not allowed to depend on x. It can only depend on things outside the function, right? And the epsilon, the delta, all of those things are outside the function, but the x is inside the function. I can't depend on x. So I need to find an actual numerical value. So I'd like to replace that x plus 4 with something, a numerical value. This is going to seem a little bit weird, but if I add 7 to every part of this inequality, why 7? Why 7? Here's why 7. So negative 1 plus 7 is 6. X minus 3 less than, negative 3 plus 7 is plus 4. This is why I did plus 7, because now I see x plus 4 in this inequality sandwich here. Oh man, that's amazing. The only problem is that I need the absolute value of x minus 4 or x plus 4. I can get here. I know I can split these two absolute values, but still that requires the absolute value of x plus 4. Well, what's the absolute value of x plus 4? I know is less than 8. It is greater than 6, but that's okay, right? I really care about the less than. I know that this is less than 8. Right? It's somewhere between 6 and 8, I know, but I know it's less than 8. So the absolute value of x plus 4 is less than 8. So let me replace this x plus 4 absolute value with 8. Now we're starting to see on the left side, or the right side here, where this is going to be very helpful to us. Draw x plus 4. I'm replacing that with 8. So I know this is less than 8. Well, how does that help? Well, now that I have this 8 here, I'll divide both sides by 8. If this is less than epsilon over 8, now I can use the other part of my initial assumption way back up at the top. I'll do this in blue. If I know that the absolute value of x minus 3 is less than epsilon over 8, that's the other part of this minimum that we assumed from the very, very beginning. And so that 8 is the m value that I'm looking for. Any m value greater than 8 satisfies this formal definition. But the smallest one that does so is 8, right? It could be 9, 10, 11, or 12, but 8 is the smallest one that gets me there. So I know that m equals 8 is the smallest value of m that satisfies the formal definition of a limit. I apologize if this feels like it's going around and around in a circle because I've got two halves of this statement, right? If the left side is true, then the right side is true. And so you can kind of see how I used both halves of this minimum statement, right, to help me out. First, I assumed it was less than 1. That's what gave me the 8 to go to the right side. Once I went to the right side with an 8, that matched the form from the left side. Oh, okay. And so epsilon over 8 is another way that I can express this. Okay? Give it a try, right? Rewatch it a few times, pause it a few times. Let me know if you have any other questions. Have a good night.